Hey there, class. Mr. Prusky here. We're having a good day so far. We are going to, this is just a video going through some of the example problems from, or some of the homework problems from 5.2 day 1 part 2, okay? So we're going to go through just a few examples. I think 1, 2, 3, 4, 5, 6, 7 examples total from this homework assignment. Hopefully this is helpful. Otherwise, the rest of the answers should be posted for you to check your work, but we're just going to focus on a few to kind of reinforce some ideas here, okay? So the first one we're going to start with is number 2. This is a very basic one, but it's a very important one for the smiley face method, okay? First thing we want to check, though, when we're solving or factoring is we want to check if there's a GCF. If you look at your factor flow chart, a GCF is the first thing we want to look for. So we want to see if there's a number or a variable that they all have in common. Well, this is a 1b squared. We can't pull out anything but a 1 if that's not going to help us, right? And this one does not have a b over here. So there's no GCF. So then we check the number of terms. And the number of terms we have is 1, 2, 3 terms here, right? We have everything between and around these addition subtraction symbols. Those are 3 terms right there. Next thing we want to check is if it's a perfect square trinomial. And on your factor flow chart, and in this case, it is not, because 7 is not a perfect square, so we can move on to general factoring, or what's called the smiley face, or the trial and error method, basically, okay? So here we go. So we're going to make some of these, and we'll do the first one. We'll kind of show the whole steps, then later on we're going to be kind of jumping ahead and not showing all the steps for everything, okay? So what are the factors of b squared? How do we get b squared? Well, the only way to get b squared is b times b. So that's nice, because that's going to be our first guess, is b times b. How do we get a positive and a subtraction? What's the only way to get negative 7 through multiplication? Well, we need a positive times a negative in order to do that, right? So we know we need a positive and a negative. And we need factors of negative 7 now. Well, the only factors of negative 7 are negative 1 times 7. And in this case, we can put the 1 right here and the 7 right here. And these should, this is 7b, this is negative b. And when you add those together, you're going to get 6b, which is what we want. So we want these outside terms to add to the middle term, which is 6b. So our final answer is going to be, this is going to be correct. It's going to be b plus 7 times b minus 1. And if we were to FOIL this, we would get back to the original problem, which is b squared plus 6b minus 7. And that's the smiley face or trial and error method. Okay, let's jump down to number 5 now. This is kind of our review a little bit. So first things first, so number 5 we're going to do next. Let's do number 5. Is there a GCF we can pull out of either of these terms right here? No, this is a 1p squared, and this one does not have a p, so we can't pull out a number or a constant for a GCF. How many terms do we have here? Hopefully you said we have 2 terms. We have 2 terms. We need to find if it's a difference of squares, that is. So we need a perfect square in the front minus a perfect square in the back. So are these both perfect squares? Well, square root of p squared is p. Square root of 16 is 4. Those are both perfect squares. So this is a difference of squares, and the factoring pattern is this. We put the first square root here, the second square root here, and then we put plus or minus between them. And this is how, if you were to FOIL this, you get back to p squared minus 16. That's all you got to do. All right, moving down to number 7. Number 7, we have x to the third, or x cubed, minus 11x squared, plus 18x. Is there a GCF for this one? We haven't found a GCF yet. Is there a number we can pull out of 1? This has got a 1, right? So no GCF for the numbers. Do we have any variables we can pull out? Well, we have x to the third, we have x squared, and we have x. What's the smallest exponent we have there? Is x to the first. So we're going to divide everything by x to the first. And we're going to pull it out in front. So we're going to have x times. The rest is going to be just kind of come along for the ride. X to the third divided by x is going to be x squared. Negative 11x squared divided by x is negative 11x. And 18x divided by x is going to be positive 18. Okay, and now what we're going to do is we're going to kind of ignore this GCF for a little while. We've got that factored out. That one's good. But now we need to take care of what's happening inside the parentheses here, okay? What does it look like what's happening inside the parentheses? Well, we got no GCF. How many terms do we have there? We have 3. Is it a perfect square trinomial? Well, this is a perfect square, but 18 is not a perfect square, so this one's not a perfect square trinomial. which is good. So that means we're doing general factoring. So we're going to go ahead and do this. So we need factors of x squared. Well, the only factors of x squared in the first place are going to be x times x. That's really nice to work with. We have a negative. Things are going to add up to a negative, but we have a positive c value, I guess. Or the only way to get a positive 18 with a negative 11x is with two negatives, right? And what are the factors of 18? Well, we got 1 times 18, and we got 2 times 9, and we got 3 times 6. So which one should I plug into the blanks there that are going to give me 11? Which ones are going to add up to 11 closely? Well, hopefully you said 2 and 9, and those are actually going to work. If you do this, you're going to get negative 2x, and you're going to get negative 9x, which equals negative 11x. This is the correct answer. So we're going to get our final answer is not just this, though. We have the x in front of here still. So our final answer is going to be x times x minus 2 times x minus 9. You could have also, if you wrote x times x minus 9 times x minus 2, that's fine. These could be rearranged. That'd be totally fine. It's not a problem. So just keep that in mind. All right, cool. Very good. Number 8, we have 3n squared plus 6n minus 105. So we need to find a GCF first of all. Is there a number that goes into 3, 6n, and 105? Well, here's a trick. Okay, this makes things a little bit easier. If you're finding the GCF of the factors of 105, that's 1 times 105, and then I don't even know the factors of 105 off the top of my head. That's like a lot to think about. So, but all you need to worry about is the factors of the smallest number. All you need to worry about is the factors of the smallest number, because even if the factors of 105 was like, I don't know, 15 or something, which is I don't know if it is or not, you can't pull a 15 out of 3, can you? Right? Does that make sense? So the only factors you got to worry about are the factors of the smallest numbers. The factors of the smallest number are 3. So all we need to do is see if, so the factors of 3 are 1 times 3. So we need to find the factors to see if 3 goes in all these numbers, because that's the only thing that we can really pull out. So what's 105 divided by 3? That's going to be 35. And we know 6 divides by 3, so we're going to pull out a 3 out of all of these. We're not going to pull out any variables, because this one doesn't have a variable. We can't pull out a variable. But that's a trick. You don't have to find the factors of 105. You just need to find the factors of the smallest number for your GCF, which makes things a lot easier. So we're going to pull out a 3 in front, then we're going to have n squared plus 2n dividing everything by 3 minus 35. Okay. So now inside the parentheses, do we have, we got our GCF. Are there, well, how many terms do we have there? We have 3 terms. Is it a perfect square trinomial? Well, 35 is not a perfect square, so it's not a perfect square trinomial. So we're going to do our smiley face methods. We're going to do factors of the first one and last one. So what are the factors of n squared? Hopefully you said n times n. We have a negative here, which means it needs to be a positive times a negative to get a negative 35 when we multiply. And then what multiplies to 35 that's going to give us 2? Well, factors of 35 are 1 times 35, or negative. And then we have 1 times negative 35, or we have 5 times negative 7, or negative 5 times 7. Okay, so what should go where? Well, we need to end up with positive 2. So let's try, I don't know, let's try 5 here and 7 here. Let's just give it a try, see what happens. 7 times n is 7n, and then 5 times 7 times negative, or 5 times, sorry, n times negative 5 is negative 5n. So this actually is the right answer. I meant to do the wrong thing first, but this is okay. This is going to equal 2n. So we actually found the right answer for this one. So our final answer is going to be 3 times n plus 7 times n minus 5. But you could also have tried, maybe you tried the wrong thing. Let's just try something different here. Maybe you tried, you put the 5 right here and the 7 right here. That would have been 5n and negative 7n, which would have been negative 2n, which is not the right answer, basically, right? So let's go back and fix that. Okay. So our final answer is going to be 3 times n plus 7 times n minus 5. All right, we're jumping back down to number 11. Number 11. So for number 11, do we have a GCF for each of any of these terms? Well, the only number, the biggest number we can pull out of all of these is 7, because 7 is a prime number and it's the smallest number. Does 7 go into 50? No, it doesn't, because 7 times 7 is 49, so that would actually not work. So there's no GCF here. How many terms do we have? We have 3 terms. And then what's the next thing? Is it a perfect square trinomial? Well, 7n squared is not a perfect square, and neither is 50, so it's not a perfect square trinomial. So we're going to do our guess and check, or our trial and error method, the smiley face method. What are the factors of 7n squared? Well, that's going to be 7n times n. And then we need to go ahead and do our guess and check here. So for this one, we need, we have a negative and we have a positive here. The only way to get a negative with a positive is that these are both negative, which is nice, because now all we need to do is guess the last numbers, which is good. So we need factors of 50. So we have negative 1 times negative 50, negative 2 times negative 25, negative 5 times negative 10, and I think that was everything. So which one should we try to end up with 75 in the middle there? Well, let's just try, I don't know. Let's see here. Let's try 25 right here and 2 right here. Let's see what happens, right? So negative 25 times n is negative 25n. 7n times negative 2 is negative 14n. That's going to be negative 39n. So we're a little bit low. So can you guys see which pair would actually work? Hopefully you can. The pair that's going to actually work, we need kind of a big number to go with 7 to get to a big number in the middle here. So we're going to put 10 right here and 5 right here. What's that? Let's see what that does. We have negative 5 times n is negative 5n. 7n times negative 10 is negative 70n. That's going to give us negative 75n. So our final answer is going to be 7n minus 5 times n minus 10. Okay, 2 more examples to try here. We got number 12. We have 15n squared plus 130n plus 240. Okay. Well, we need factors of, we need a GCF. So we need the biggest number that goes into 15 and 130 and 240. So factors of 15 are 1, 3, 5, and 15. And so the biggest number that goes in, if you divide these by, 240 doesn't divide by 15. So we're going to actually divide by 5. 5 is going to be the GCF for all of these. And 240 doesn't have an n, so we're not going to pull out an n. So we're going to have 5 times 3n squared, divide everything by 5, plus 26n, plus 48. Okay? So we check inside the parentheses now. We got our GCF. How many terms do we have inside the parentheses? We have 3 terms. Is it a perfect square trinomial? Nope, these are not perfect squares, so that's not going to work. If it's not a perfect square trinomial, we're going to do guess and check. So we're going to do our smiley face method. So we need factors of 3n squared. Factors of 3n squared are going to be 3n times n. And they're all positive, so we're going to have a positive times a positive, which is nice. And then let's go ahead and do some guessing and checking now. We need factors of 48. So factors of 48 are 1 times 48, 2 times 24, 3 times 16, and 6 times 8. So we need to match these factors that are going to give us 26 in the middle. So let's figure out, let's see here. Let's try 6 and 8. Let's try 6 right here and 8 right here. That's going to give us, this is not a huge number, but it's still kind of big, so we need some kind of decent sized numbers. This is going to give us 6n. This is going to give us 24n, which is going to give us 24n plus 6n is going to be 30n, which is going to be really close to 28, which is 26, which is what we want in the middle. So we're actually not going to do, let's try switching those around. That was pretty close. If you're pretty close, to switch the numbers around, see if that works. So we have 8 times n is 8n, 3n times 6 is 18n, and that's going to be 26n. So our final answer is going to be 5 times 3n plus 8 times n plus 6. Okay. All right, and then number 15 is the last one we're going to do today. So number 15, is there a GCF we can pull out of here? Well, the factors of 4, which is the smallest number, are 1, 2, and 4. Can we pull off 1, 2, or 4 out of 25? Well, we can't, so that's not going to work. Is this how many terms do we have here? We have 3 terms. Is it a perfect square trinomial? It looks like it might be because the square root of 4x squared is 2x. That's a perfect square. Square root of 36 is 6. But we have to check the middle too. The middle is going to be double these square roots multiplied together. 6 times 2x. It's double. It's a, b, and it's a squared, b squared, and it's double a times b. All right? So let's check that though. What is 6 times 2x is 12x? What's 2 times 12x? Is that 25x? It is not. So this looks really close to being a perfect square trinomial, but it's actually not. Okay? So we need to go ahead and solve this now. So we need to, let's erase this stuff here. So we need to do smiley face method. So we need factors of 4x squared. That's either going to be 4x times x or 2x times 2x. Let's try 2x and 2x for now. And this is a negative and a positive, so these are going to both be negative in the middle, which is nice. And the factors of 36 are negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12, negative 4 times negative 9, and negative 6 times negative 6. Okay. Let's just try some notes. We need to end up with 25x in the middle, so let's try, probably not 6 and 6. Let's try 9 and 4, see what happens. So that's going to be negative 9x times 2x is going to be negative 18x. This is going to give us negative 8x, which is going to be negative 26x. That's really close. That's very, very close. So we're going to switch this around. I'm actually not going to mess with, since we're pretty close, I think these numbers are probably the closest ones we're going to get. So I would stick with the negative 9 and 4. I'm going to switch, what I'm going to do is I'm going to change it to 4x and x. See if that fixes it for us. So negative 9 times x is negative 9x, and then 4x times negative 4 is negative 16x, and that will fix it, which is going to be negative 25x. So our final answer is going to be 4x minus 9 times x minus 4. All right, and that should be your final problem for today. Thanks for watching. Have a great day. We will see you soon.